Today, we are going to use Reaxys to do a natural language search in order to investigate how or what targets will be the best to look at in the RAS family for cancer treatment. And so I'm going to begin using a text in natural language to ask the question in Reaxys. I will go ahead and paste in my question, which says, which RAS family member should we target for cancer treatment? Going to select search. Reaxys will do a search and provide us with an AI summary in our results page. So you can see we have 1,465 documents that are related to our search. You can also see we have AI-driven insights that we'll be able to view as a summary in the results. You can see at the top here, our summary has loaded in. You also still have information and access to references below that you can review. So in the actual reference, you have title, bibliographic information, as well as access to index terms, abstract, and substances, and a link out to the full text. When we go up into our summary, we can select View Full Summary. And in that summary, what you'll see is that targeting RAS family members for cancer treatment, we have key points of context where it has been identified that KRAS is the most frequently mutated RAS family member in cancer and has historically been considered undruggable, but there are advancements happening in the space. Then you can also see an ideal target for cancer therapy, as well as some additional information. You have a summary table. In that summary table, you have the frequency of mutation, clinical targeting status, cancer types, and then therapeutic approaches that have been identified, and then some recommendations, as well as individual references for each of those recommendations. If you'd like to view each of the recommendations here, or references within the summary, you can click references and it will show you the full list of references. You can also click on references individually. Based on this, we want to do further analysis just to take a look at bioactivity information as well. And to do that, I'm going to do a more advanced search in Reaxys' Advanced Search Query Builder. Within the Query Builder, I will select target names from Reaxys. So I can click this, and I'm going to add, in this instance, 3. And then I am going to change some information here. So under the Boolean operator, I'm going to change these both to OR because I'm interested in seeing KRAS, NRAS, and HRAS as part of my search as potential targets. And so now that I've put the target names and the Boolean operator of interest, I'm going to select targets. This will run the search. It's going to pull forward a list of targets that I could review. One thing that Reaxys does have is this measurement px value. It allows you to limit down to those substances with higher activity on our targets. I can limit to it. And then once these load in, you'll have access to the same types of information, a view of the substance and a view of each of the targets. And then you can go into our Bioactivity Visualizer. And what this allows you to do is look at bioactivity across all of the substances that you're interested in. We can sort by the activity here. So we bring the highest level activity to the top. And when we review those substances that have high activity, you can see that GTP-KRAS has some of the highest prevalence of activity for the substance interactions with the targets. Based on this, we can say that KRAS is a target that we could have interest in for cancer treatment, and we could pursue looking at this particular target in a higher frequency to target for our cancer treatments.